Hello! This video is a brief overview of the design and assembly of a high-capacity portable solar generator that doubles as a mission-critical uninterrupted power supply, or UPS. While many commercial solar generators are closed-box systems, this build utilizes modular, high-grade amateur radio components to ensure maximum field serviceability, high current delivery for HF operations, and efficient power management. We will look at how this system provides a seamless transition between solar, AC mains, and battery reserves. Our technical walkthrough will follow this roadmap. We'll define the system architecture and the role of a solar generator in a ham radio context. I will detail the bill of materials and why these specific components were selected. We will analyze the system's power handling capabilities and electrical specifications. You'll look at the internal and external physical configurations. Finally, we will discuss practical applications, from field day to emergency home station backup. Technically, a solar generator is an integrated energy management system. In this build, it consists of three primary stages: energy harvest, the solar panels; energy storage, the LiFePO4 battery; and energy distribution, the DC power rail and optional AC inversion. For our purposes, we are focused on maintaining a stable 12-volt DC rail. Unlike consumer units that often prioritize AC outlets, this system is optimized for native DC equipment to minimize conversion losses, though it remains capable of supporting an external inverter if AC is required for peripheral gear. Now, we will define what a solar generator is in a broad sense. Essentially a portable energy storage system fed by the sun. It's important to recognize that not all generators are created equal. Technically, a solar generator is an integrated energy management system. In this build, it consists of three primary stages: energy harvest, the solar panels; energy storage, the LiFePO4 battery; and energy distribution, the DC power rail and optional AC inversion. For our purposes, we are focused on maintaining a stable 12-volt DC rail. Unlike consumer units that often prioritize AC outlets, this system is optimized for native DC equipment to minimize conversion losses, though it remains capable of supporting an external inverter if AC is required for peripheral gear. The reliability of any power system is only as good as its weakest link. The core components of this build include storage, a LiTime 12-volt 100 amp-hour mini LiFePO4 battery, chosen for its high energy density and compact form factor. Management, the West Mountain Radio EPIC PWR gate, which acts as the brain of the system. Harvesting, an Allpowers SP029 140-watt foldable solar panel. Interfacing, PowerWorks panel pole housings and QC 3.0 USB ports for standardized connectivity. Housing, the Harbor Freight Apache 3800, a ruggedized IP65-rated weather-resistant case. Now that we've established that a solar generator is essentially a portable battery storage system powered by solar panels, we need to look at how to build one that meets the high-performance demands of amateur radio. While the concept of converting solar energy to stored DC power is straightforward, the reliability of the system depends entirely on the quality of its internal architecture. To achieve the goals of a small footprint and autonomous power management, I carefully selected a group of specialized materials. Let's dive into the major components that make this system a hitless UPS and a rugged field power source. When designing this system, I established four primary engineering requirements. Small footprint. It had to be man-portable and fit within the Apache 3800 chassis. Solar integration. The system must utilize an MPPT, maximum power point tracking, controller to maximize solar yield. Note that the EPIC PWR gate requires a solar panel with an open circuit voltage of 30 V or less. Autonomous switching. The system must automatically arbitrate between solar, a DC power supply, and the battery without manual intervention or relay chatter. No mechanical switching. To ensure a hitless transition for digital modes and sensitive electronics, the power must be delivered via a solid-state OR gate. The EPIC PWR gate is the centerpiece of the system. It is a high-power OR gate rated at 40 amperes continuous duty at 12 volts DC. It features a very low voltage drop across the FETs and integrates a smart multi-stage charger. It supports both lead-acid and lithium chemistries and includes a USB port for real-time performance monitoring and firmware configuration. This ensures that your transceiver is always seeing the cleanest, most stable voltage possible. The storage medium is a 1280 watt-hour WH lithium iron phosphate battery. We chose LiFePO4 over traditional AGM for several reasons. Cycle life. It offers thousands of charge cycles compared to hundreds for lead-acid. Discharge profile. It maintains a flat voltage curve, staying above 12.0 V until nearly depleted. Safety. The Lifetime Mini is heat-resistant and IP65 waterproof. Current delivery. It supports a 100 amp continuous discharge rate, meaning it can easily handle the 20 to 25 amp peaks of a 100 watt HF transceiver without voltage sag. My setup requires an auxiliary power source. I've integrated a combination Quick Charge 3.0 and USB-C port power delivery. This is not just for charging phones. Many modern tablets used for digital modes, like FT8 or WinLink, require high wattage USB-C power delivery. I use this to power my Raspberry Pi and monitor. A critical feature of this specific component is the integrated blue LED voltmeter. This provides an instant at-a-glance diagnostic of the battery's state of charge when the system is under load. Standardization is key in ham radio. The PanelPole 2 provides a weather-tight, dual-port Anderson power pole interface. These are rated for 30 amps continuous, matching the standard power cables for most HF rigs. Using these panel-mounted connectors, we maintain the weather integrity of the Apache case while allowing for rapid deployment and teardown in the field without ever having to open the lid and expose the internal wiring to the elements. In addition to the dual output, I have installed a dedicated PanelPole 1. This serves as the primary DC input for an external AC to DC power supply. By separating the input and output rails, we can clearly label the chassis for power in versus radio out. This prevents accidental cross-connection in high-stress emergency environments and ensures that the EPIC PWR gate is correctly receiving the 14.5 volts to 15.0 volts input required to trigger its internal battery charging logic. The solar panel connection interface, I selected the PanelPole GZ. This is a specialized housing designed for vertically stacked power pole connectors. The technical advantage here is its compatibility with Goal Zero style solar cables, which are common in the portable power market. This allows the system to remain vendor neutral. I can plug in my 140 watt all powers panel or bridge into a friend's Goal Zero array without needing to rebuild cables in the field. It's mounted to provide a weather-sealed input directly to the EPIC PWR gate solar controller. We've just gone through the ingredients of this build, from the high-density Li-Time battery to the intelligent EPIC power gate and the ruggedized Apache chassis. Having high-quality components is the first step, but for a mission-critical power system, the magic happens in the execution. It's not enough to just throw these parts in a box. They have to be configured to talk to each other correctly. Let's move away from the what and start looking at the how. Internally, the EPIC PWR gate must be configured correctly for the LiFePO4 chemistry. This is done via internal jumpers or the USB software interface. Voltage logic. The PWR gate requires a solar input voltage greater than 13 volts to initiate the MPPT charging cycle. Mains charging. When using an external AC to DC power supply, I recommend setting that supply to between 14.5 volts and 15.0 volts. This ensures the PWR gate has enough headroom to properly execute the CCCV, constant current, constant voltage charging profile, required to bring the 100 amp hour battery to a 100% state of charge while simultaneously powering the radio. This diagram illustrates the parallel integration of the three power sources. The EPIC PTWR gate acts as a solid-state switch. Under normal operation, your DC power supply runs the radio and charges the battery. If solar is available, the MPPT controller leverages that energy to offset the load. The critical feature for us as hams is the hitless transfer. If your AC mains fail, the FETs switch to battery power in microseconds, faster than any mechanical relay, ensuring your digital nodes or HF rigs don't reboot mid-transmission. Let's look at the hard numbers for this build. Total weight, 28 pounds. For a 100 amp-hour system, this is exceptionally light, thanks to the Li-Fi 4 chemistry. Energy density, 1,280 watt-hours. To put that in perspective, you could run a 100-watt transceiver at a 25% duty cycle for nearly 40 hours without a single ray of sun. Power limits. It supports a maximum continuous output of 512 watts. This provides plenty of overhead for a 100-watt rig, a laptop, and several peripherals simultaneously without stressing the internal bus. While we think of this as a field box, it is an excellent uninterrupted power supply, UPS, for a home station or a remote repeater site. One specific feature for the DXers, MPPT controllers can sometimes generate RFI. The EPIC PWR gate includes a suspend button. Pressing this pauses the solar charging circuit for 30 minutes, allowing you to work a weak signal in a completely RF silent environment without disconnecting cables, after which charging automatically resumes. To manage a battery budget effectively, you need more than just a voltmeter. I recommend using an inline power analyzer between the generator and the rig. This allows you to track peak amperage to ensure you aren't exceeding the power gate's 40 amp limit, accumulated amp hours to know exactly how much capacity you've pulled from the 100 amp hour reserve, watt hours for a more precise measurement of total energy consumption. It's the fuel gauge that ensures you don't go dark unexpectedly during an emergency net. In summary, this build provides a ruggedized, high-capacity power solution that solves the common power gap in portable operations. Whether you are operating field day, a POTA activation, or keeping your home station alive during a grid failure, the combination of LiFePO 4 density and the EPIC PowerGate switching logic offers a professional-grade power backbone. It's modular, serviceable, and built to the standards we expect in amateur radio. Thank you for viewing.